Welcome back. In previous lecture, we talked about the valve actuator symbols, which give me a clear information about how the valve will operate. And we start talking about hydraulic cylinders or actuators symbols. We specifically talked about the single acting hydraulic cylinders. We understood the mode of operation and how the force created by applying pressure on the piston area will lead to a movement of the hydraulic cylinder piston to a certain distance. We have also calculated this force and displacement of the stroke or the stroke of that piston. So we are calling the movement of this piston as either displacement or stroke. In this lecture, we'll continue with the hydraulic cylinder symbols, and we will talk mainly on the double acting hydraulic cylinders. So let's start with lecture number 17. We'll continue discussing the control of acting hydraulic cylinders, and we'll talk about the double acting cylinder. The difference between the double acting and single acting, as we explained in previous lecture, that the single acting has only one single port or connections where the hydraulic fluid can enter. While in double acting cylinder we have two ports. In single acting cylinder, the extension stroke done by hydraulic fluid and the retraction will done normally by gravity or by spring. For double acting cylinder can be extended or retracted hydraulically. Hydraulically means by hydraulic oil pressure through entering either in port A or port B. So in port A, if the hydraulic enters, it will push the piston to extension, and then if any fluids here will be drained through port B, and for the retraction stroke, the fluid will enter through port B, and then the drain will come through port A. And in this case, the output force can be applied in both directions. The output force and the piston velocity of a double acting cylinder are not the same for extension and retraction strokes. Why they are not the same? Because if we recall the formula of calculating the force equal P multiplied by the area. And here we have two different areas. In port A, or we call this area as piston side, the pressure of the fluid will act equally in all areas and impact the piston area. While in other side, we call it rod side. And rod side, the area here will be equal the piston area minus the rod area. So during extension stroke, fluid enters the blanked end A of the cylinder through the entire circular area of the piston. However, during retraction stroke, fluid will enter the rod side through the smaller annular area between the rod and the cylinder bore. Therefore, AP, the piston area, and AR is the rod area. Since AP is greater than AP minus R, then the retraction velocity is greater than the extension velocity since the pump flow rate is constant. And it is obvious because here I have lesser area than here. Similarly, during the extension stroke, fluid pressure bears on the entire area of the piston, AP. However, during the retraction stroke, fluid bears on the smaller area, which is AP minus AR. The different area accounts for the difference in the output force, with the output force is greater during the extension. So, to refresh the formula, when we are doing an extending stroke, we have the force extend equal P, constant pressure, multiplied by piston area, and the velocity of this piston movement can be calculated through Q divided by area piston. However, for the retraction stroke, I have the force of retraction will be equal P multiplied by the area, which is area piston minus area rod, and the velocity during the traction stroke will equal the flow rate divided by the area of the piston minus the area of stroke. It can be seen from those four equations that the force during extension is bigger than during retraction, and the velocity of the piston during the retraction stroke is greater than extension stroke, provided that the same operating pressure and flow rate. So, one more topic to discuss, which is the power developed, and the power developed by the hydraulic cylinder for either the extension or retraction stroke can be found by the velocity multiplied by force or flow rate multiplied by pressure. This is the power. Now let's demonstrate an example with hydraulic simples for a hydraulic system, and to see how it will work and how we can see the movement of the piston in reaction to the pump flow of hydraulic oils. So if we can see here, we have a pump with motor, filter, pressure regulator, and then drain. After that, a control valve, and this control valve, 3 positions, because I have here 3 envelopes, and 4-way, because I have 4 ports, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and a hydraulic cylinder. So this figure shows a circuit used to control a double-acting hydraulic cylinder. When the 4-way valve is in centered configuration, like what we have here, now it is in centered configuration, the cylinder is hydraulically locked, as the ports A and B are blocked. Hence, the pump flow is unloaded back to the tank at essentially atmospheric pressure. So this is we call locking or holding position. And before going to the other positions, let's refresh our understanding in some of the rules, and to refresh it again. Extending stroke, F extension equal P multiplied by area piston, and the velocity will be the flow rate divided by area piston. For the retraction stroke, we'll have the F retract equal pressure multiplied area piston and area piston minus area rod, and the velocity will be flow rate divided area piston minus area rod. This is a 3D sample of how the piston, or how we calculate the area. I have here, this is piston and this is the rod. The AP or area piston equal normal, like normal circle, the force is applied by d square over 4, and here this area will be equal to area piston minus area rod. Now let's see when the valve will be shifted to another position. Now, if you can see here and observe the hydraulic oil coming from the pump. If we see here the hydraulic oil moving, going to port A, and then led the piston to have a stroke in extension mode, and the remaining fluid will be drained back to the tank. To calculate this force and the velocity using the same equations during extension stroke. If you go to the third position, where the retraction mode now, or retracting position, the pump will give the oil flow going to the third position and pushing the piston in retract mode, and the remaining fluid will be drained through port A to the tank. This hydraulic symbol explains this operation, which we can see here. See, this is the hydraulic cylinder, and we have here 2 ports, 1 and 2. Here doing extension stroke and then retraction stroke. And it is obvious that the force during the extension stroke is much, or is bigger than the retraction stroke. Thank you. And before telling you go to the next lecture, I just want to highlight that after this lecture, you will find a quiz to demonstrate your understanding in reading the hydraulic symbols and how to calculate the force and velocity of a hydraulic cylinder. Thank you and see you in the next lecture.